Hello, in this part of lecture, I am going to discuss some MCQ question. This question is also taken from Nagrath and Kothari book, MCQ question. So first question is, 6 ampere current is here and these two resistances are in parallel and these are the resistances as shown here. So here in this question, it is asked to find the Ix, means current in 6 ohm we have to calculate. So let us see how we can find. So these two resistances, if you see, these are in parallel. So these are the parallel resistances, and I draw it's a circuit like this. It will be like this. This circuit will be like this, and 6 ampere current is flowing. So this resistance is the equivalent of these two resistance, 6 and 8, 3. 6 and 3 ohm resistance. So it's equivalent, these two are in parallel. So 6 multiplied by 3 divided by 6 plus 3. So its equivalent will be 6 into 3 divided by 6 plus 3. So it will be 2 ohm. So this is 2, this is 2, this is 2 also, and this is 6. So this equal resistance will be 6, and here it is 6 ampere. So 6 and 6 are in parallel. So we can draw this circuit like this, 6 and 6, and equivalent resistance. This is 6 ampere, this is 6 ohm, and this is 6 ohm also. So the current division rule we can apply. So these two resistances are equal. So directly we can say here 3 ampere current will go here and 3 ampere current will go here. It means 3 ampere current is being going here and 3 ampere current will go here. Because two resistances are equal, so equal distribution of current will take place. Means if 2 ampere, 3 ampere current will go here. So these 3 ampere current now will be divided into two sections, this and this. So you can draw the equivalent circuit like this. Means here we can draw this circuit like this, and here current is coming how much? It is 3 ampere current is coming here. 3 ampere current is coming, and this is 3 ohm, and this is 6 ohm. So we have to find current in 6 ohm, that is Ix. So Ix will be equal to, just multiply this current by the parallel resistance, 3 into 3 divided by both the resistance in parallel. So it will be 9, and it is how much? It is also 9. So it will be 1 ampere. So here 1 ampere current will go. Here in Ix 1 ampere current will go, and if someone asks what will be then 3 ohm resistance, then 2 ampere current. So Ix will be 1 ampere. Correct option is C. Let us see another example. 3 resistance of value R ohm, each are connected in a star. So this resistance, you see, this is connected in a star. This is R, this is R, this is R, and we have to find its equivalent resistance in delta. So this connection is, I'm taking some different color, so that this color. So this is in delta. So it is asked to find the value of the delta equivalent resistance, R delta. What will be the delta equivalent? So R delta resistance is, using the formula, means we have to multiply all the resistances like this, R into R, this resistance by this resistance, then this resistance by this resistance, and this resistance by this resistance, R into R plus R into R, and divided by the opposite arm, whatever the opposite arm, this is R. So R. So it will be 3R. So its equivalent resistance in the delta, it will be B, means 3R will be the correct option. Now we are coming to the third problem. This is also very interesting problem. And in this question, it is asked to impedance matrix R and input voltage vector V for the circuit. We have to draw the input matrix. So here C, just applying Kirchhoff voltage law, I1, I2. So this current I1 is going in 1 ohm. So this 2 ohm resistance is for I1, and this resistance 1 ohm is common for I2 also. So in writing nodal equation, mesh equation for loop number 1, for loop 1, this is loop number 1. So mesh equation means this I1 will be multiplied by 1 plus 1. All the resistances of this loop, 1 plus 1. And this I2 is also common for this 1 ohm resistance. So we have to subtract it, I2 multiplied by 1. And then here we are coming, it is entry point is negative, so we have to write it as negative, minus 1 equal to 0. So let us see how much it is coming. It is coming 2I1 minus 1 into I2 equal to 1. This is equation number 1. And I'm going to write the Kirchhoff voltage law for the loop number 2. And for loop number 2, for this loop, you see here the current which is going into this loop is I2. And I1 is also going here downward, and this is upward. So we can write I2 multiplied by 1 plus 1 and minus I1 into 1 and plus 1 will be equal to 0. So here we can see that it is I1. So minus 1 I1 plus 2 I2 equal to minus 1. So this is our relation. So we can write the answer asking in the form of matrix. So we see here that I1 is multiplied by here minus 1, and here I1 is multiplied by 2. So this relation, you see, if I write in the form of matrix, so what we will get? So first of all, we have to write the value of the coefficient of I1. So coefficient of I1 is here 2, and coefficient of I1 is here minus 1. Again, coefficient of I2 is here. Coefficient of I2 is here how much? In this equation, we can see that what is the value of impedance matrix. Now you see we can transfer it in the matrix form. So here you see this is the correct matrix form. So I1 multiplied by 2 minus I2. So if you see this one equation will come 2I1 minus I2, and if I multiply this I1 minus I1 plus 2I2, so this equation will come which is equal to minus 1. So correct option is this one is where, so you can see this is the correct option, 2 minus 1 minus 1 2 1 minus 1. This is the correct answer for the resistance of this matrix. Now let us see the another example. Here again we have one more interesting problem. Figure shows admittance matrix G and input vector current RR respectively. Input current and admittance matrix we need to calculate. So in applying the nodal analysis, we can see here only current source are needed, and it is also given in the question. So right now we have to write the nodal equation at the node 1 and node 2. So we can see directly how many elements are how many conductance. Here this is conductance number 1, 2 and 3. 3 conductances are connected with this node, and one current source is given here. So we can directly write this equation as V1 multiplied by 1 plus 2. This is in moho. You can remember that this is not resistance, it is conductance. So we have directly to multiply voltage by summing all the conductances directly connected with this node. So we have written this. Now we have to come across this portion 1 ohm, and this 1 ohm is also connected with node 2. This is also connected with node 2. So we have to subtract this 2 value V2 into 1 minus V2 into 1. This is 1, this is 1 also. So we have to subtract because this element is connected to the node 1 as well as node 2. So in adding node 1, all these elements are considered here, and this is common. So we have to subtract node 2 multiplied by this conductance and node 2 multiplied by this conductance, and this current is coming as a input, as a inside current. So we have to take it as negative equal to 0. All outgoing currents are taken as positive and incoming current are taken as negative. So how much it will be? It will be 4 multiplied by V1 minus 2V2 equal to 1. Let us write this as equation number 1. Now we come across the equation 2. So how can we write the equation 2? Use the same thing. Here you can see at the node 2 how many conductance are connected. 1, 2, 3. 3 conductances are connected. So directly we add all these conductances. If it is given in resistance, we have to convert first in conductance, but it is given in conductance itself, so no need to convert it into conductance. So all three are added. Now again see this resistance and this resistance again connected with the node number 1. So we have to subtract it by V1 multiplied by 1 minus V1 multiplied by 1, because two are connected and this current is going outside, so we have to take it as positive equal to 0. So here minus 2V1 plus 4, 5, 6 V2 equal to minus 1. So you can now check what is, now we can write this equation in the matrix form. So I am writing here, this is our voltage V1 and V2, and this is conductance multiplied and this here current I1, current matrix I, that will be in the first equation it is 1 and in the second equation it is minus 1, and V1 and V2. So V1 coefficient in the first is 4, and then we can write here minus 2, and for another it is minus 2 and it is 6. So let us see which one this option is. So 4 minus 2 and 6, but this one 4 minus 2 minus 2 6 1 and minus 1. So this is the correct option. So you can see here many options are matching with this, but this option, this is the correct answer, which is A. This is very interesting question. 2.4. Okay, thank you. Next we will see another MCQ in next video.